Greetings everyone, Damon Caskey here with well, not a Let's Anything, this is just a quickie for class. We are going to be doing a sort of follow along addendum to Mr. Zach Talley's tutorial. Sorry if I'm mangling your name. We are working with the Circuit Express microcontrollers. Unfortunately, mine has not arrived. I'm very bereft. I do have some microcontrollers, but they don't have LED arrays, and right now they're all busy controlling other things. One of them's on a homemade hovercraft, the other is controlling some remote stuff in my garage. So anyway, point being is I don't have one in my hand I can show you, but thankfully we can simulate one on screen. You may also notice that we are looking at a bit of code, and this is why I'm doing this. I want to put a different spin on here because thus far the tutorials I see are using blocks. Now, some of you may not be familiar with code or you're a little afraid of code. I understand that. I feel the same way about the puzzle blocks. I don't like them. I don't use them. They annoy me. It is much simpler since I have a coding background to just write what I want. And I think that you'll find ultimately that if you give coding a try, you'll find the ability to granularly do exactly what you want, no more, no less, will make you never want to touch those blocks again. So if you've never seen this before, I'm going to talk you all the way through it, and hopefully you'll be ready and willing to try some of your own. Now right now you can see that the microcontroller is all green, not particularly useful, but it's just kind of a test bed. The way that is working right now should be kind of obvious. We have light and we have the object show ring. JavaScript is what we call an object-oriented programming language. Everything is done in objects. So we have object, and then we have our members. And then of course we have our codes and executors, functions, whatnot. So this is our object light. Its function is show ring, and it takes a parameter for each LED, and those are text. So I could say type blue here, and as long as that is one that it recognizes, then we will see that I just set the LED here to blue. And we can type green to put it back. Give it a sec for it to read the code, and there we go. But we can do just a little bit more than that. This code down here isn't just for looks. It is to turn our microcontroller into a thermometer. So if I comment this out and I go down and I uncomment our final line, you'll notice that we have some blue and some red. And the way this is working is it is reading ambient temperature and then making a calculation and setting our LEDs accordingly. So the lower the temperature, the bluer the LEDs. Well, not bluer, but the more blue we get as compared to red. So if I turn it all the way up, well, then we get all the way to red. All right, so how do we make this work? Well, this is where the walkthrough happens. First, we set up a forever function because that means that it's going to run on every iteration of the microcontroller, and it will run as long as the microcontroller is operable. Then that is the event. Then it's going to execute this block function, and we need to set up some variables. The first one is temperature. That is an integer variable, and that is going to be the ambient temperature from the microcontroller's temperature sensor. Then we need a count of red LEDs, a count of blue LEDs. We need a loop cursor, and then we need the string for ring. The next thing that we need to do is start populating these. So right here we have our temperature variable, and of course it started out as 0, but instead of staying at 0, we are going to get input temperature, and you can notice that by looking at some of these inputs. If you check these out, you've got a lot of different, you've got events, I've got light conditions, acceleration, sound level, pretty much everything the microcontroller is capable of, and here is the temperature. And setting that up also lets you set up this temperature simulator. Now, this will get the temperature unit of Celsius, and it populates this variable. So, and this is data from the device populate into temperature. So at this point, temperature is now 36. The next thing that we're going to do is a proportional map. Now, in a lot of other languages, you would have to write this yourself doing some math. Thankfully, this one gives us a function that will do it for us. So we have map, there's math, and of course math gives us all kinds of functions here. Lots of algebra, a little bit of trig, a little calculus. But this one does a proportional range to range. So it accepts the temperature parameter. That's what it's going to map from. And then it's going to read that temperature. And this is the range of temperature that it can read, 0 to 50. And it will map that from 0 to 10. So in other words, if this is 25, then this is going to be 5. It's going to find the closest proportional match in this range to this range. Very handy function. And then it's going to populate that with count red. The next math function that we're going to run is called constrain, and it's a little more obvious. It accepts a variable and it outputs a constrained value from that variable between the ranges you provide. In this case, 0 to 10. We have 10 LEDs, so if our range happens to fall outside of 0 or 10, we need to constrain it. So if it's -1, caps it to 0. If it's 11 above, it caps it to 10. Then we do a little bit of math magic here. So our temperature from red has been calculated as a proportionate of the ambient temperature here. Well, since we have blue and it's the opposite, well, all we have to do is take the number of LEDs that are available, and we subtract the number of LEDs that we are going to light red, and that's going to be how many we are going to light blue. All that remains now is to convert that into a string. So for that, we're going to use a for loop. Now, for loops are very handy as long as you don't have an endless loop, because that will crash the microcontroller. It is made up of 3 expressions. The first is the starting expression, then we have the conditional, and then we have here where I stick my iterator. So the first conditional here, first expression, is going to set the loop to 0. It should already be 0 from up here, but this just makes sure, right? Then, each time the loop runs, it is going to check this conditional. It will continue to run as long as our loop cursor is less than count red. So in other words, it's going to count 0 to, in the case of, let's say the temperature is 23 degrees, it's going to count 0 to 5, and then that will stop. And each time it goes, this is what actually iterates that 0 to 5. So 0, 1, 2, 3, 4, then it hits 5, and that's where it stops. So that's 0, 1, 2, 3, 4, except we're on the red side, so it's really 0, 1, 2, 3, 4, counting around. And each time it does that, it is going to concatenate red into our red string and a space. So we are building this string right here. And thus far, we have red, 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 and then empty. Now, empty isn't going to do us much good. We have to have something for all those LEDs. So here we do the opposite. We check our blue cursor, or a blue count, excuse me. So we run a cursor up to our blue count, and then we concatenate our string with blue. So now it's going to add the remainder of blue, 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 and blue. And then finally, it will pass that string into our light show ring, and then our microcontroller will act accordingly, and it will illuminate the LEDs, giving us a nice little simulated temperature readout. So look there, it's really cold outside. Now it's getting pretty warm. And something in between. So I hope that helps you out, shows you that, code is not that scary at all. You can play around with it, try different things. The worst you can possibly do is make something not work, and you can always just erase it and start over again. If you have any questions, hit me up. I'll be glad to help you out. Everybody, thanks for listening, and we'll see you next time.